Okay, so guys, thank you. Before I begin, I do want to say thank you to Argen and Donnie for reaching out to me and LMT for organizing this event. Oh, sorry, just 1 minute. Hello? Not a good time right now. Okay, all right, okay. Hey Siri,
Uh-huh.
I just got a call from Dr. Jones. I'm in New York right now at Lab Day East. Can we make some clear aligners and have them delivered?
Who do you want to send it to?
Dr. Jones's office?
Affirmative. Making a set of clear aligners. Hope your lecture goes well.
Me too.
And right now, I'll let Minh make the honors of you taking it out.
All right, how do you do that?
Just pop out the aligner. Oh, you're ready to go. You're ready to go. Yeah. And all you gotta do is you peel out the separator. I'll let Katie do that for you. There we go.
That's awesome. Look at that.
Ready to go in the mouth.
Huh. That's amazing. So yeah, that was just a video of some stuff that we'll be kind of unpacking today, discussing a little bit, and just kind of where the future of dental technology is going to be going. For those of you who don't know me, my name is Minh. I'm a dental technician based out of Windsor, Ontario, and this is not working for some reason. Okay. Been a technician since 2006, spent the majority of the time behind a computer using a mouse and keyboard, primarily on 3Shape, but I've used a wide variety of digital technology in that time. And in my spare time, I run a blog called Dental Tech Tips, where we focus on the latest and greatest in dental technology. So if you want to find me or follow me online, you can find me in all the usual places by liking or following at Dental Tech Tips. And I just want to take a quick moment to speak about Dental Tech Tips as an organization and why it was founded and kind of the purpose of it. Very often we go to trade shows, very much like this one, and you see all these speakers and they're very well regarded, high accolades, very well respected, and they know their stuff, right? But I hate to say it, but very often you find that they're just, industry mouthpieces who are just selling products to whoever's the highest bidder. And you trust what they say, you like their products, but when you order them, you bring them back into the lab, they're not necessarily quite as good as they promised. And that just never really sat right with me. And around the time that I had founded Dental Tech Tips, one of my big passions, of course, is cameras, photography, making videos like that one that I just showed you guys earlier. And this was me around 2015. I bought like a T5, Canon T5, my first big boy camera. And this was like on a Black Friday sale. And this was, look at this guy, he's so artistic, taking a photo of himself in a reflection mirror, because no one's ever done that before. But, as a technician, I spend all my time in a dental lab. So the only thing I had things to take photos of, videos of course, were dental lab things. So you start making little reviews, posting them up online, on forums, on groups, and you catch the attention of manufacturers and they go, hey, you know what, we really like what you did there. Your feedback is pretty much in line with what all the other customers are saying. Is it okay if we just send you some stuff? You can try it out, let us know what you think. And you get free stuff. Who doesn't love getting free stuff, right? That's really awesome. And making these videos with my T5 camera, I quickly realized that, if I was shooting overhead, I couldn't see what I was filming because it didn't have that screen. I couldn't plug a microphone in. So eventually we got to like doing some sponsored content. I think it was like a couple $100 for my first video. And I took that, I sold my original camera, I bought the next one up, the T5i with the tilty flippy screen. And you know, you could plug a recording in. So I always made it a point to, whenever I finish a project, to take some of that money and reinvest it in camera equipment. So really, Dental Tech Tips was founded as a way to fund my seriously unhealthy addiction to camera gear. And I mean, seriously unhealthy, right? This is like my little dungeon in the basement with my Renford mobile scope, a little handpiece, some hemostats. I'd buy lenses off eBay. I've had cracked glass. You buy a new glass element, reseat them in. On the, you know, the selfish side, on the more personal side, that was Dental Tech Tips. But on the more altruistic side, it was really founded as a way to be a voice in the dental lab industry, an industry that's really just given me so many opportunities I've grown up in, and offering some unbiased information to the best of my abilities. So, you know, dental technicians all over the world can really, you know, have someone to trust, and it's not just in anybody's pocket. So that's Dental Tech Tips kind of in a nutshell. Hopefully it helps paint a little bit of a better picture of why I do what I do. And the content that I'll be going over today, of course, is all the products I'm mentioning. Nobody's paying me to say anything. I have no financial interest. Full disclosure, I'm receiving an honorarium from Argen for discussing all these topics today, but they have no say in what I'll be discussing, and the opinions are wholly my own. So let's move on to the topic, of course, of navigation. So navigation, the first thing that you think of when you see the word navigation is, of course, like a GPS in your car or Google Maps, right? But the root of the word navigation itself, it's Latin, it shares the same root as the word navy. So let's use the brand newly christened Trios 5 that was just introduced a couple weeks ago, this cruise ship here, and we're going to use that to help explore this vast ocean that is digital dental technology. And very often when you're working with cases, large cases in particular, you have an end goal in mind, right? You want to get to you want to treat something, you want to meet a specific concern that the patient has. So when working on these cases, you want to have a certain goal in mind. And very much like navigating, if you want to get from point A to point B, and you know that your trip is going to take 2 hours, you're going to get up at 9, you're going to arrive there at 11. If you sleep in past your alarm and you wake up at 9:30 and you punch your destination in Google Maps, you're going to arrive at 11:30, right? You can't eliminate that time loss. But you know, if you woke up and you said, you know what, I'm gonna get there at some point, I don't know what time it's gonna be, you don't really have a plan, no GPS, things can get really, really messy. So taking the time to really plan your case outcomes is very much like punching something into your GPS, and having that set in Google Maps, even if there's, you know, an accident, a delay, a detour, it'll recalculate and get you to your destination in a predictable manner. So very much like if you want to do a full arch all on X with implants and all this stuff, and you want to do bone guides the same day, let's say, you know what, you don't get enough initial stability, or, you know, they had to remove more bone, or they couldn't remove that much bone. What's your contingency plan? How do you recalculate to get to that endpoint in a predictable and efficient manner? So keep this in mind with all the things that we're going on about today. And I really think we are living in what I think is the best time to be a dental technician. And I just want to give you a little bit of a background on how the digital technology has really created a paradigm shift in how the digital technology and the relationship with the dental technician and the whole team. So
I can
this little clip
explain.
here.
You are making $500,000 and you were only going to pay me 30?
You're getting 30 grand? I'm getting 1,000.
You guys are getting paid?
Aside from not getting paid, there's quite a few challenges with being a dental technician. And the NBC, of course, where you get your CDT, kind of defines these as within the scope of practice of a dental technician, right? And you can take an exam for crown and bridge or dentures or implants. In Canada, we have an RDT. You have to pass all of these to be a registered dental technician. But a dental technician today is not just somebody who knows about these 5 things. A dental technician today is expected to be a data management expert, a technical advisor, an IT aficionado, machine servicer, material science wizard, treatment plan coordinator, customer service representative, salesman, social media guru, client educator, and I could just kind of go on and on and on about all the different things we do. But I think you guys get the point. So in my example here, a dental technician in 1963, for example, could have gotten a job when the PFM was introduced, and they could have started by casting a coping, putting some opaque, and then slapping some porcelain on top. And they could have done that for 40 years and not done anything else, and they would have been just able to retire. In contrast, my career started with making some zirconia copings where you couldn't even scan anything but the die and just made a coping. layered some porcelain on over top just to kind of mimic the PFM workflow. And then of course we had the rise of monolithic and all that. And now we can press Emacs, we can mill Emacs. You of course have intraoral scanners, you have implants and screw retain implants, angulated screw channels, and of course now the advent of additive technologies. So quite the contrast between the two here. And I wrote an article not too long ago in DTG magazine. You can actually take a picture of that QR code if you want to actually read it. But it just highlights the paradigm shift that we've experienced, and it's called the rise of the digital technician, right? And there's an image of me and some colleagues and near and dear friends, and actually my new boss right here. But yeah, it's just a fun little thing, and it really just highlights how, you know, in the past you'd go into a building, any lab really, and the most sought after, the most knowledgeable, the most skilled person in the building typically was the ceramist. And that was the position that was kind of the coveted, because they were the ones that signed off on these crowns. But what this article here details is kind of a paradigm shift away from that, and that position now being the digital dental technician and how technologies have enabled that. And we really are experiencing a repositioning of the dental technician as a whole in the team, right? Dental technicians were typically regarded as kind of like the pariahs of the dental community. You know, you're like in some dungeon with like a lab coat with wax all over the place. And, you know, they're used to scribbling something on the lab script. Okay, the lab technician will take care of it, right? But really, now with digital technology, we're given the driver's seat, kind of front and center. And I'm a huge advocate of involving the dental technician early and often in the initial planning stages, because we have the tools. We know how to use them. We know what's possible with the materials, what's possible with machining, with additive technologies. So we can drive these cases if we're involved early and often. So over the next decade, you know, in the 2020s, 2030s, it's just going to completely change how we make teeth and just how high-end dentistry is regarded, right? It's not going to be some guy who can, you know, lick 23 different colors and put them all together. It's going to be armed with all these powerful libraries, all this powerful technology, CBC technology, that you can actually see inside and plan ahead of time. So these kind of cases are going to be driven by, you know, highly skilled, interdisciplinary, and really highly skilled technicians. So where do we start with navigating, right? And I kind of break it down into this 4 steps of navigating digital highway, and we're going to use this to kind of go over each of the case examples that I'm going to show you. So you want to plan your destination. I'm a huge advocate of planning, and we'll kind of go over that. Gathering the appropriate tools, right? So we do a lot of just-in-time manufacturing where you order implant components right before you need them. That's kind of biting everyone in the ass right now with kind of the supply chain shortages that we're experiencing. But yeah, you want to make sure that when you're investing in digital technologies as well, do your research, do your homework, make sure that make sure that the printer that you're using is compatible with the CAD software that you're using, and making sure that you're able to integrate this all into your current ecosystem. Navigating in real time. So again, I grew up around Detroit, Michigan, so I got automotive in my veins. So now we got self-driving technologies. If you don't own a Tesla, then, you know, you can put cruise control, lane keep assist, brake assist, different things like that. So in my analogy here is with delivering these things to your doctor, you can give them tools to help them navigate their case in real time as well, right? So we'll cover some of that as well. And then one more travel analogy here, preparing for your arrival. So yesterday I flew in from Detroit, Michigan over here to Westchester Airport, and we're flying, and about 30 minutes before we start landing, he goes, ladies and gentlemen, we're going to begin our descent into Westchester Airport. Please fasten your seatbelts, make sure your tray tables are up, you know, seat in the upright position, stuff under the seat. And what they're doing is they're preparing you for your arrival. And very much like that, we want to make sure that we're scheduling these cases appropriately. Technology is, you're able to do things much faster, you're able to do things much easier, but that's not necessarily why we're adopting technology. You want to make sure you're scheduling these things appropriately. Just because you can fasten a crown doesn't mean you should fasten them all the time. Just because you can mill a crown in 20 minutes doesn't mean you do it the day before, right? So scheduling your cases accordingly, making sure that whatever data you're getting back from the office is appropriate for what your final outcome, and adjusting your final case outcome to match that. So in this example here, again, we're going to start with smile design. I'm a huge advocate of doing smile designs and diagnostics. And the reason is people are just very, very visual, right? They don't understand that, okay, well, you know, you're going into protrusive and you're causing excess wear on your incisors and we need to open you up and do all this. They don't understand that. They understand that it looks like this and it could look like this, right? You give them this in the chair and they go, okay, that's really powerful. I look like this, I want this, right? So as a visual aid, this helps to really increase case acceptance. And smile designs are very, very simple to do. You just snap a couple pictures and just overlay using a little bit of software. You don't even need to use software. You could use Microsoft Paint, Photoshop. It doesn't really matter. You just put it in there and just mirror a tooth, do something very simple, but you can get some great results if without software, but if you have the software, that helps a lot too. Next, you can always pair these with a digital diagnostic. I'm a big advocate of calling a digital diagnostic, not a wax up, because we don't use wax anymore. But you know, you use the built-in smile libraries that you have within 3Shape. You can 3D print your wax ups, and then of course you can create templates, right? So we'll kind of go over some steps here. And digital diagnostics, if you want to see how me go in a little bit more detail about it, I did do a lecture for Argen there. You can scan that QR code in, take a picture, or just hop on their YouTube channel. You can see how we take digital diagnostics and then we kind of copy and paste those from the initial all the way kind of to the end to kind of simplify your whole workflow, right? And then, of course, we're going to speak a little bit about guided solutions as well in this diagnostic and in this planning phase, right? So guided preparations, guided surgery, they're all prosthetically driven. They're all from the top down rather than the bottom up that we're used to, you know? So it results in better aesthetic outcomes, better final outcomes, and much more predictability. So in this case example here, you know, the patient shows up to the doctor's office and says, I don't like how gummy my smile is, right? And that's the chief complaint that they want to address. If I didn't bring this into software, I could just say, yeah, you know what, just do a little bit of crown lengthening and then we'll make some crowns. But what the doctor did, we take some pictures, we do a smile design, right? So planning your destination, right? So bring it into software, do a smile design, do a diagnostic, and when I brought it in and I start playing with it, I go, you know what? We actually only probably need to do like the anterior 8, not much more than that. We could probably even get away with just the canines. So we communicate back and forth with the doctor, and she says, yeah, I think I agree with that. So then, of course, we're going to gather the appropriate tools. What do we need, right? We use smile design software already. We use CAD software. We're going to 3D print some things. We're going to do some suck down templates. We're going to make some matrices for the temps and everything like that. So, of course, I do my design. That's the overlay. And then when I make it, I lop off the top 2/3 there. So we have a nice stop to make this perio guide. And we clean this all up. I used to do this in custom tray and 3Shape, but I actually just like using like a clear S6 retainer suck down. And the reason for that is it's just a little bit quicker. And now we're navigating in real time, right? This is where you're providing a perio guide to the doctor, right? So this is guiding them. This is like cruise control. It's like lane keep assist. And navigating in real time, I'm a huge advocate again, because it's not a replacement. Technology is not a replacement for clinical skill or technical skill. This right here, the patient had some kind of reaction to the freezing, so they were swelled up. You can see how blanched the tissues are. So the doctor, thinking on their feet, marked it with a marker, right? And then they free-handed it rather than using the actual perio guide. And then once they're done, they're all healed up from that. We made them some prep guides as well. These 3D printed prep guides, you do it in the Splint studio, actually in 3Shape. And you make these prep guides. This one here is like an incisal guide, tells you how much incisal clearance. This is your interproximal guide, how much interproximal clearance they have. And this is kind of like for your labial surfaces to make sure you have enough clearance there. So I made these for her, and she put them in and she did some guided preparation. Instead of doing these things freehand, it's based off of that final outcome that we want to get to. And then, you know, preparing for arrival. The prep is going to be a little bit different from what we planned, and we just design according to that. And this is what the final design was and what the final outcome is. So pretty close and pretty good result. So guided surgery, very much like guided preps, same thing. Prosthetic driven, top down versus bottom up, and you get better outcomes. So I'll highlight another case and kind of how those 4 steps again apply here. So with this, we use the dual scan protocol. So we duplicated the patient's existing denture, and we made it in a print material, and we put some radiographic markers inside there. They scanned it, they sent it to us. And then again, we're going to bring it into the software. We're going to plan, right? And I initially planned this as an all-on 6. And I show this to the doctor, and he goes, you know what, those back ones near the molar sites, the patient opens like this big. I can't get my get back there to put 2 more implants. So can we just distalize those bicuspid ones and make them an all-on 4 instead? So we adjust the plan as needed to kind of match that. And then, of course, next thing, gather your appropriate tools. What do we need, right? So now in this software, what I'm able to do is I'm able to visualize where the angulation of these implants is coming out. And you can see, you know what, I need to angulate these in because we don't want the access holes coming out of any aesthetic areas. So now I know, you know what, with this tissue overlaid on top of the CBCT, with that duplicate denture, I need multi-unit abutments that are angled 17 degrees each, and with the tissue, roughly we need 2.5 millimeter collar height for each one. So now we can order those parts, have them ready. He knows that he needs, you know, 3.5 millimeter implants, and they're like all 11 millimeters in length. So you're really preparing ahead of time and making sure that you have all the componentry that you need. And of course, we provide them with a guide here, with some guide sleeves in there. And again, this is always just kind of a reference, because you can't do fully guided surgery. You should really be doing brain guided surgery, right? So making sure that if anything changes mid-surgery, that they're able to still adapt to that. And then, of course, the last thing is preparing for your arrival. So sometimes if you're in surgery, you can't get enough initial stability. You can't get, something goes wrong. They got to bury these things. What's your contingency plan there? So what do? We use 3D printing, and I just printed a Flexera denture there. And this, I just give it to them because I had the design already, right? I had my design from my initial. So I'll give them a printed one. They can give that to them until we can get some stability later on. So we deliver all this to the doctor, and that's what they have for the day of surgery. And this is kind of the roadmap for what navigating this planning stage is kind of like. And some associated tools. So I'm going to speak a little bit about the tools. So Smile Design, we need photography equipment. We have the Smile Design software, retractors. In a digital diagnostic, you're going to use the CAD software. You're going to need some kind of impression, either a digital or PVS. You're going to need a 3D printer to fabricate things, and then of course some kind of matrix material. And then same thing in the guide solutions. You can see there's a lot of overlap here, like 3D printers are needed almost in these two. You're going to need CAD software in all three. And this is where I'm going to go next, is really kind of focusing on the software, right? So I'm a big 3Shape guy. It's just my software preference, just because I've been using it forever. You hear this analogy all the time, you know, 3Shape is very much like the Apple ecosystem, right? And an ecosystem very much is nice because all these things are interoperable with each other. If I get a Trio scan in, I know it's going to import very easily, and it's going to be fully compatible with the 3Shape dental system. If I plan my implants in Implant Studio, those implant coordinates will be dragged into Implant Studio, so I can make a temporary that's going to match to those implant coordinates that we planned. If I do a Smile Design, I can import those into my dental system to have a 2D overlay. So this is really nice because you have like a very nice, neat package that you can use. But you know what? If you're an exocad person, you can go ahead and use their Smile Creator software. They have CAD software as well, and you can plan in exocad, right? And navigating these types of things, I'm a huge advocate of using a system just because it makes it a lot simpler for you. But you can definitely go piecemeal as well, right? So if you want to use like the Smile Design app, you can download that on your iPad. If you want to use Medit Smile Design, they have a free app for that. If you want to use Blender, you can use that. And planning in either Romexis or Blue Sky Plan, the big problem with this, of course, is you're not going to be able to import a Blue Sky BSB file into your Blender to make a temporary, right? You're going to need some kind of intermediary. So that there's, with trying to go and get different packages on your own, you're going to lose some of the interoperability. And there's nothing wrong with that. I use Blue Sky Plan a lot just because I'm a huge fan of some of their tools. And number two, I like their subscription model, right? You design for free everything, and when you save it, that's when something is spit out and you just pay for that one case. So it's kind of like a pay-as-you-go. Over the lifetime of it, it's probably going to be more expensive than Implant Studio. But you know what? If you don't have the volume for an Implant Studio license, this is a great option to kind of get started, right? So if you want to get into implant planning, look at some of these programs, or if you're not doing a lot of CAD right now, this is free. Just download a Medit. You can do Medit Smile Design. If you want Blender for dental, I think it's like a couple $100 for the license. And same thing with Blue Sky Plan. So there's a lot of ways to get into digital without fully investing into an ecosystem either. Okay, good. And it gets even more complex when you look at all the different intraoral scanners, right? Because they all have their own file formats, they all have their own portals. And on our next stop, ladies and gentlemen, you can see here the dental technician in its natural habitat checking in cases from all the different portals. So I'm sure some of you who are working with digital impressions right now probably feel this pain. We have, well, at the lab I used to work at, we had one person dedicated to checking in cases from all the different portals and bringing them in to the lab management software. And they really do have a whole bunch of different portals. Like I said, 3Shape is great because it just gets fed directly into my 3Shape. But all these other ones, they need to be able to export formats. 3Shape is working with a lot of these, and you can just select those orders and you can import them in. But sometimes what we need to do is we have doctors transferring things to us either via Dropbox or WeTransfer or via email. The one thing we really need to be careful about with this is you want to make sure that you're HIPAA compliant when doing this, right? So email is not a HIPAA compliant form of communication unless you have a HIPAA compliant email service that you're signed up for. And Dropbox, WeTransfer, same thing. As long as there's no patient information being transmitted. I know Romex is here that I showed earlier. What they do is they encrypt, and it's like a long string of numbers, and then there's a separate one with a password just to make sure they're compliant when they're emailing these things. So again, you want to make sure that whatever the process is, that's why, again, I'm a huge advocate of using these programs because they're HIPAA compliant data transfer methods. So when navigating these, make sure that you're remaining, compliant with that and protected. So how do we get these things to work together, right? They have all these different file formats. They have all these, and it's very confusing, very overwhelming if you don't know how to get one file into a different system. There's got to be a better way, right? Of course. So the STL file is kind of like the de facto 3D file format for our industry and just kind of 3D in general. So the STL is like a stereo, they say it stands for stereolithography, but it's just a collection of dots and triangles that represents a shape. And all of those softwares I was showing you earlier are able to export STL. Sometimes it costs a little bit extra, but they're all able to export an STL file, and they're all able to import STL files. So that's how you kind of act as an intermediary between all these programs to get them to work with each other. So going back to 3Shape, of course, because it's my software of choice. It's a very good program, and navigating 3Shape is very overwhelming as well because they have all these different programs. So I'm not going to show you how to navigate 3Shape because that's a 3-day course on its own, but I'll do with a couple basics. So navigating the control panel here, be very careful, ladies and gentlemen. This is your first lesson.
Ding 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 ding
So don't let your junior designers play around in control panel. I've actually had that happen. He's like, oh yeah, I cleaned it up and I just removed one thing and it would not start up. So that was not a fun day. But yeah, so with 3Shape to navigate, I'm going to do a very, very fundamental thing here, and that's just navigating 3D space. So if you're not in designing anything, you're not doing anything 3D at the moment, I just want to impart a little bit of fundamental knowledge on you. So even if you've been using it for a while, some people don't understand this as well. But when you're working with this, what you see here is likened to a picture, right? What a lot of people who don't understand this intuitively is it looks like you're looking at a picture, right? What we're actually working with, though, is a 3D object projected onto a 2D plane, right? So if you want to imagine working in 3D space, rather than looking at a picture, it's actually a window that you're looking through, and the object is virtually behind that screen. Right, so to kind of wrap your head around this, it helps a lot because then you're able to visualize these things and work in 3D and understand that it has virtual depth. Right, dental technicians, we're very tactile people. We like to pick things up, inspect them, blow on them, lick brushes and things like that. With this, you kind of remove that intuitiveness and you have to work virtually, which is kind of muting for a lot of people. So when working with 3Shape, understanding that principle, what you need to understand as well is when you're sculpting things in 3Shape, it has that virtual depth. So everything that you're working with when sculpting, you're either pushing away from the screen perpendicular to you or you're pulling towards you. So here you can see I'm sculpting, but if you don't have that understanding of depth perception, it looks like a little lump. But if we rotate this screen a little bit, you're going to see, oh, I'm moving in this area. But when we rotate, you can see that it has quite a bit of depth. Right? So even though it doesn't look on the screen like we've done a lot, when you have to kind of wrap your head around, unless you work with 3D glasses, you're not going to have that depth perception, right? And same thing if you go remove, and when you're removing, you're going to be pushing away from the screen, right? Away from you. So right now it doesn't look like much from here because you don't have that depth perception. But if you rotate and move things around, you can see there's quite a bit of depth that's been removed from that spot there. Another thing about navigating 3D space is understanding how the mouse works, right? The mouse, of course, has 3 different functions for navigating 3D space. If you use the zoom function here, by using the scroll wheel, you're moving in and out, right? You're moving the object away from you or pulling it closer. That's zooming in. If you press down on the mouse button and you move the screen around, you're panning. So you're moving it perpendicular to yourself, but parallel to the screen. And then, of course, zooming or orbiting with a right click and you rotate, that's how you orbit the object around. So just some fundamentals of how to navigate around and understanding what you're actually doing when interacting with these objects. So now we're going to go to navigating digital dentures. Complete dentures, digital dentures is a very exciting segment right now because there's a lot of investment, a lot of innovation, a lot of excitement around this because it's really the thing that's being digitized the most right now. And there's a lot of really good workflows now. I'd still say the most reliable way of doing things is via milling because you get the best results, the strongest results. But we are getting a lot of good printing results as well. And this is kind of the roadmap of what it looks like to work with dentures digitally. You have all your impressions, whatever else, all that data you need to feed into your CAD software, you design it, and then we'll speak about manufacturing pathways a little bit later. And this is what a traditional workflow for a denture would look like, right? You have like 2, 3, and if you were some of my dentists, then, you know, so they always think there's a reline at the end. And I'm not going to say, you know what, go out tomorrow and start telling your doctor that if we go digital, we can do dentures in one appointment. But I think it's really good to highlight this because it shows what is possible, right? And this is not the standard, but it is definitely the exception. But it was some great results, and it highlights some of the things that digital helps us to do that we couldn't do traditionally. So this here, and I apologize, this video is quite literally taken by a potato, and like as a camera guy, it really hurts me. But it really highlights the results and kind of. It's really great, so let's play that.
Hey, Minh Tran here. Just wanted to show you the denture that we did for Alice Meerhofer here. We scanned this one a couple weeks ago, and then I just took a bite with some base plate wax. But here's the fit. You wouldn't think that it would be very retentive just with the short borders, but check this out. Okay, let's see, Alice. I'm just going to seat it again here. And just going to fire it in there. And as soon as it goes in, it's, you can open there. It is in there tight, which is pretty crazy. So just wanted to say thanks for a good denture there.
So you can see here, this is the trio scan that he sent me here. Very short borders, and I'll show you here as well. So he did the upper trio scan, scanned the lower teeth, those were the teeth, and a sheet of folded up base plate wax there for the bite. So I pick up the phone immediately. I go, on the script he said, yeah, let's take this to finish. I go, are you sure? He goes, yeah, the lady's like 93 years old. She lives in like a village like 200 miles away from him, and her son had to drive her in, and getting her back in for any kind of try-in is probably going to be impossible. So they just want to take it to finish. So, of course, the traditional wisdom with doing dentures traditionally is you used to carve a posterior palatal seal here so to account for polymerization shrinkage. But with doing dentures digitally, we don't have any polymerization shrinkage, so we don't do those anymore. But with this, because we had such short borders and to ensure we had a lot more retention, we did do a butterfly post dam there. And as you saw in those results there, you had quite a bit of suction there. So again, using traditional knowledge and pairing that with our digital technology, you're able to get some really good results. And of course, Dr. Dobson there, he's very technical. He's very good with his scanner. Most doctors I wouldn't trust necessarily. He also told me that he would do a reline if needed, right? So there's a lot of asterisks and caveats to this, but you know, it is possible. So don't go out tomorrow and tell your doctors that you can do, you know, single appointment dentures, because that's just a lot of chaos in your life that you don't want to introduce. But yeah, at least it is an option. It kind of highlights what we're able to do with digital dentures and what digital technology allows us to do. So this is what your traditional workflow looks like again. And this is what that single appointment denture looked like. But what I really recommend more so is like this 2-ish denture appointment roadmap. So going through doing your impression scan, your designs, printing your try-in, doing a try-in, doing a wash or a bite, capture all that in, bring it back in, and then you're able to modify your design very quickly. The nice thing again about doing dentures digitally is resets don't take very much time, right? I can do a reset digitally in about 10 minutes, right? And 5 of those are spent waiting for 3Shape to load. Whereas if you're if you're doing dentures traditionally, if you're doing a reset, that's a full reset. That's 40 minutes an hour if you're really skilled. And then of course you can print or mill your dentures and then, you know, take it through assembly and then finally to delivery. And this photo really highlights another powerful thing about working with dentures digitally is everything is completed in a non-destructive manner from one step to the next. Where if you're doing things conventionally, you lose the subsequent step, right? So if you like to set your teeth in the bite block so you have that right buccal corridor, you don't have this wax rim anymore. If you like then when you process the denture, you're going to lose the wax up, right? And then, but instead, we're able to go back and refer to this data and use it in a non-destructive manner if we need a reference and say, hey, you know, how does this compare to what the try-in was? We can scan these in, compare them. So this non-destructive manner is very powerful for looking back and using it as data for references. And then, of course, we're going to speak a little bit about navigating orthodontics. And I really think orthodontics is the final frontier for digital, the final frontier there. So, yeah, one thing that I use quite a bit is clear aligners, actually. And we owe a lot of the innovation of 3D printing in general to one company that, of course, is Align. They are the largest producer of parts, printed parts in the world, not just dental, but just 3D printed parts in general. And they print upwards of 400,000 models per day. So that's a massive scale of printing. So if you're thinking of clear aligners, you're not going to compete with Align, right? Because they have so many efficiencies and they've just done it so well. But clear aligners, the way that I frame it and the way that we've offered it to our doctors is as an addition to treatment to move things into final restorative positions. We offer it as kind of like a loss leader, just as like a budget option that maybe, you know what, certain patients that they want to offer clear aligners to. The other things you can do with orthodontics, of course, are indirect bonding trays. That saves doctors a lot of time if they just set all these things in, they go in and bond all these together. And then, of course, orthodontic appliances, there is bending wires and different things like that. Still very much in its infancy. They need to get wire gauges a little bit thinner. But yeah, orthodontics is a very exciting kind of spot for digital dentistry and where that's moving. But I'll highlight one case here that we use clear aligners kind of in a creative way. So this patient here, she's pretty young, and the doctor sends me this picture and he's like, oh, I'll call you about this. And I go, well, she doesn't really need anything, right? And he goes, yeah, everything is fine, except that if you look at her lingual surfaces here, she's got quite a bit of erosion right on the anteriors here. And he goes, well, what can we do there? He's like, she's a really young girl. I don't want to just cut all these off and do full crowns. Can we do something a little bit more creative? So I remember reading an article about lingual veneers, actually. So I said, you know what? Yeah, we can definitely do some lingual veneers for her. And he goes, well, I don't want to prep into those because she doesn't have much tooth structure left. And whatever she has, minimal enamel she has there, he wants to preserve so he could bond something to. So I go, you know what? Light bulb moment. Let's use some clear aligners, right? So this one here, I think was just the video for it. But there's no clearance between the uppers and lowers. But once again, you plan for your destination. So we take these, we send them off to Full Contour, who did the planning. I show him the plan here. And the whole idea was just to intrude these teeth enough so we could have some restorative space there to do these lingual veneers. It was just a few trays. It was a couple months. A little bit of IPR on the lowers as well, just to get those teeth to lingualize a little bit. And he signs off on this plan. We get the patient to wear them. Again, gathering those appropriate tools, right? So we need to be able to produce these. We didn't have the laser aligner cutter at the time. We had to do them manually. But yeah, and again, navigating in real time. This here, again, when she needed a couple changes, he had to do a little bit more IPR in between. But once we got to that stage here, she's got a little bit of clearance there. So now we could do some veneers, lingual veneers at least. And he's prepped just a little bit. I told him, you know what, we're probably going to have to do a little bit of reduction on the opposing teeth as well, the lower incisors. And then finally, I helped him with the delivery a little bit, so I brought those in there. We got those pick and sticks to make sure that you had something to hold on to, make sure you have good isolation everywhere.
So what kind of veneers do you use?
Actually, we did these in Vita and Namic, so we did composite actually, just because we put I can't remember what but he put like almost like a primer on the tooth surface, and he bonded the Vita and Namic to that. And you can see here, that's the before. This is before, that's after. And it really doesn't look like much was done, but it really helps eliminate a lot of that sensitivity for her. So if you do things right, sometimes people won't be sure you did anything at all, but it really did help her out. So, of course, speaking about clear aligners, we did in-house aligners because we did enough of them that it made sense to get this laser aligner cutter. And what's nice is if you have people trying to cut these out manually, there's dust flying everywhere, everyone's miserable, your arm feels like you're going to develop carpal tunnel. But if you don't want to invest in something like this, Argen, of course, offers a solution for that, right? So you can fire it off to full contour, and if you don't want to manufacture in-house, you can push this up and have it decentralized in terms of manufacturing. And we'll discuss a little bit more about the differences between centralized and decentralized manufacturing in just a little bit. But I'll just cover the last thing here, of course, and that's implants, right? Navigating implants. Implants, there's over 150 different implant companies with all their own different components and their own naming systems and their own catalogs and everything like that. This implant company here, they have their own workflow. This one here has a completely different workflow. And this one, maybe they don't even do anything digital at all. But so how do you navigate this, right? The answer to that, of course, is you use kind of a third-party system, so like Argen IS and some other companies, desks, things like that, and you're able to use this decision tree. So we try to always do a screw-retained restoration as much as possible because doctors want to avoid cement as much as possible. So the first question I always ask myself, can it be screw-retained? Yes or no, right? And we kind of go through this decision tree until we find a component that works well for that specific case. So yeah, with implants, you have all these different options now. You can use titanium bases, very, very popular option. If that doesn't work, you need to fill a larger space, you can always use prefab custom abutments where you can pre-mill them, or you can send them off to be custom milled. Screw-mentable crowns where you use that custom abutment and then you make the crown over top with an access hole, right? So you still have that cementless philosophy there. And then of course hybrids for bars, overdentures, different things like that. So there's a lot to unpack there with implants, but at least this is some of the ways that you're able to treat and navigate implants. The other big thing, of course, is making sure that when you're working with these things that you understand FDA compliance. This is a whole topic all on its own. I'm not an expert in it at all, but my friend Tim Torbenson is, Evo 820. If you want to get into implants, you can check out some of his content, check out some of his webinars on how to be compliant when working with FDA compliance and implant systems and making sure your quality management systems are compliant there. And then now we're going to speak about manufacturing methods. So very much like that laser aligner cutter and sending off to somebody like Argen, there's nothing wrong with outsourcing, right? Outsourcing is like kind of this negative word, because you hear like being sent overseas or something like that. But there's nothing wrong with outsourcing. If you're a one-man operation and you can't do everything, there's nothing wrong with sending it off to a company that has the facilities, the capability to be able to help you with that. So very much if you're a CAD designer, you can, of course, mill it on your mill in-house. But if you don't have enough volume to justify that, send it off to an outsourcing center until you develop that volume, right? And then look at getting a mill for yourself, and you can start offloading some of that. And the way that I always look at it when investing in equipment is, if I can pay for the machine by myself with the volume that I'm sending to outsourcing, then that's great. But in the meantime, use your outsourcing partners as a way to help augment your production capacity. Same thing if you're a ceramist and you don't want to get designing, right? You took a course and you're like, I'm using this mouse and I don't know how to do anything with it. And it's just wasting all your time, but you're an excellent ceramist, outsource, right? So there's design centers that you're able to outsource to, but also you could also find remote designers, right? So I feel like right now we're going to be going through another paradigm shift where there's going to be a lot of decentralization in the way that we work with each other. There's a lot more collaboration in the way that we work with each other. So, of course, if And for dentures as well, right? If you want to outsource some of your production, but insource some of the stuff, that's fine too. So you can design your dentures, you can print your try-ins internally. But milling dentures, printing dentures, all this stuff is very difficult, very time consuming. And if you don't know how to mill them properly, you can get some really bad results. So again, find a partner that's able to mill your finals, but you can produce your temporaries or anything like that internally. And of course, manufacturing pathways, when we break them down, it's broken down into either reductive or additive material in manufacturing processes. So the additive ones are, of course, printing, SLM, things like that, and milling is milling zirconia, milling metals. And it's a very mature segment of manufacturing. We've been milling things forever. You get very good tolerances, you get very good results, but there is a lot of waste and it's very time consuming and you're very limited by the tool geometry. If you have undercuts, you have to account for your burrs, your tool paths to make sure that you're milling things properly. And this is a picture of me in 2006. We had this milling machine back then, and it only accepted RFID discs. You had to scan on an RFID reader and enter it all in, and you could only order the zirconia from that manufacturer. But over time, and nowadays you can order discs from any of these manufacturers, and they will work with any of these milling machines, because we as the end users have dictated that the 98 millimeter standard is what works for all of us, right? And a lot of these manufacturers didn't have that standard before, but eventually it kind of converged on this, and now we have interoperability with pretty much anybody, right? 3D printing, it's kind of following that same track, right? You have all these different 3D printers. When I first started doing presentations, I had this one. This was one of my first ones. And the technologies were completely different. All these material systems were different, closed systems. You know, the only one that was open really was the Asiga. Carbon was open as well, but, you know, they were really expensive. Whereas if you look at it today, a lot of these are now moving towards open systems, right? Because again, we as the end users have dictated that we want to be able to use the materials that are the best, right? If a company comes out and says, you know what, you can't choose a different resin, and then you compete to somebody else, and you can't use that resin that's better, you've lost your competitive advantage, right? So open is the way forward for materials, and making sure that you're choosing an open printer is very important to make sure that, you know, you're future-proofing your investment. So, of course, the other thing when navigating 3D printing is you have this printer, it has this technology, it has all these different things, and they're not standard at all. The way that I like to compare printers so you get a more apples to apples comparison is you look at the price per square millimeter. So when you're searching for real estate, you look at the price per square foot, right? And you can look at each individual property and go, okay, that's pretty competitive. When you're looking at printers, look at this price per square millimeter. That gives you a very good idea of the value that you're getting, of the volume to the amount that you're able to produce. Not necessarily the only key critical factor, because there's different technologies, there's different resin wavelengths and different things that you also need to consider, but this is one way to really compare printers and make it a little bit more level and understand things. And of course, I did do a webinar on the ROI of 3D printing, so if you check that QR code up there, you can watch that. It's just different indications we're able to do, kind of the rough costs per unit of different printing indications and things like that. And also, if you want to see this one here we did in collaboration with Evident, it was comparing a $150 printer versus, you know, a $100,000 printer, and how they perform and all the differences between and what you should really be looking for. So QR code right there if you want to watch that later. But the one thing I do want to highlight, of course, is, and in that last one, because we used an Anycubic photon printer versus, you know, all these other dental printers. The Anycubics and the Frozens are hobby printers, as they're called. And the big thing I'm a huge advocate, again with being compliant, is using validated workflows, FDA compliant workflows when printing, because you're compliant, but you're also ensuring patient safety. So this one happened recently online. I blurred out some names just to keep people, anonymous. But somebody had asked a question, and they said, "Oh, my splints are breaking, and we don't know why." So somebody chimed in. And they said, "Oh, you know, just mix 2 parts flexible resin with 1 part non-flexible resin. You'll be fine." This is not Mrs. Smith's home economics class. Okay, you can't just add a little bit more sugar in there and then it's going to adjust your recipe. These are finely engineered resins, right? So we can't experiment on things. We got to make sure that we're compliant and using validated workflows to ensure that the things going into the patient's bodies are safe and not, you know, going to lead to adverse effects or cytotoxicity, anything like that. So some predictions moving forward. Everything is being digitized, even the way that our support, our education, everything. So your support has been digitized. You can have people remote in and help you with things. Everything has kind of been democratized. I'm a huge advocate of going on Facebook groups, going on forums, and some of the groups have over 30,000 members, and you get instantaneous support. We're going to be discussing social media, digital, and all that stuff a little bit later after Jack's. We're going to have a panel. And it's like a democratization of our industry, right? And it really allows the best of the best to trickle to the top. Like, if a product isn't good, we talk to each other, we speak to each other, and eventually you find out soon enough that, you know what, this is not the one that anyone wants to buy. And every day online, I'm a huge advocate of going online, but it's like going to a lab day every single day. You learn something new from somebody online, and where before you'd go to a trade show, once or twice a year, you catch a beer, maybe they share some tips with you, maybe they don't, right? Where online, everyone is so collaborative, they're really willing to share, so it's a great resource of going digital. And the other big things for digital, you will save time, right? I'm not a huge advocate of saving time and cramming more stuff and doing more work, but I think time savings to allow for better work-life balance, that's a huge thing. And it won't be realized immediately, right? If you're just getting into digital, you're not going to be an expert right away. So my first denture setup I ever did, I was there for like 3 hours, and it was just like a waxy mess all over the place. I had to throw it away and start over again. When you're working with digital, it's going to be the exact same way. You're going to have to be patient. You're going to have to practice and practice and practice until you get to somewhere where you're proficient with it. And practice really does make perfect. But it really does result in better quality, better time management, and just better results overall. So some predictions and what certain things we want to watch out for. Of course, an additive, which I think is going to be very big. Printed permanent crown resins, we'll get there eventually. There are some very exciting materials right now that we're experimenting with, and we'll see how they're going to be in the next couple of years in terms of long-term real world use. In the beginning video there, you saw a Rapid Shape with their automation, right? This is huge because when you do large volumes, you're able to automate a lot of those processes all the way through. 3Shape Automate for designs, automating your prints. Automation is the only way forward, kind of, in terms of being able to meet the demands that are going to be coming in the future. Affordable desktop SLM. So they're going to have a lot more desktop metal sintering options, right, for laser sintering. So a lot more printing in smaller offices and things like that. And of course, jetting technology is very, very exciting. I won't get too much into the nuances of it, but what we're using right now is photopolymer resins that are stereolithography printed. Jetting technology allows for multiple prints, multiple colors, multiple materials all at once, and you get these really complex multi-material prints. And a couple predictions for the future. So we're going to have a lot more increased adoption of those intraoral scanners I was telling you about, and less desktop lab scanners, just because doctors will be scanning more and we'll be scanning less. I think we'll always have a desktop scanner in the lab, and just to digitize certain things, like you print something, you need to scan it back in. But I feel like intraoral scanners will be the way forward in terms of getting digital data in. Automation, again, decentralized production, right? So sending to a remote designer somewhere. Because if you're from a small town, maybe you don't have the talent pool for it. So there's nothing wrong with outsourcing and sending things to the cloud, having somebody design it for you, having somebody produce it for you. It's, again, the way forward in terms of being able to augment our production capacity. And then a lot more additive applications, right? So better resins, better technology, it's really going to be the majority of things will be done in an additive manner rather than milling in the future. So, yeah, we got about 5 minutes or so. Okay. Yeah, so I just want to tell you guys a little bit, like just an anecdote here. I'm a huge advocate of having the time to play, right? None of this would be possible if I wasn't granted the time to play and experiment and try all these different technologies. And a lot of companies, large companies, have this thing, it's called 20% time, right? So if you have a Gmail account, who has a Gmail account? That was made in 20% time. So it's somebody's project there, right? And it just gives you the ability to explore, to play, and to really innovate. And it kind of ties into our navigation theme as well. So it's October 1957, and Sputnik from Russia was launched into orbit, right? And there's this man-made object floating around in space. So there's these two researchers from Johns Hopkins University, I can't remember the name, William Geyer and George Wiffenbach, and they're enthusiasts, right? And they're radio enthusiasts, and they go, hey, you know what? There's this object floating around in space, and it's probably broadcasting some kind of signal, something. We should really go back to the office. They had radio equipment there. We should try and listen for it. So they go back to the office, and soon enough they hear beep, beep, beep. So they're listening in, and it's really interesting. And then one of their colleagues walks by and says, hey, what are you guys doing there? They go, oh, we're listening to Sputnik. You know, we're probably one of the first people in the world, if the United States for sure, that are listening to this noise. So they go, oh, you know what? I got a tape recorder. I'll bring it into your office here, and we're going to record those little bleeps and bloops. So really cool. They start recording these things, and that's just really awesome. Nothing really comes of it, and they're tracking the trajectory of this, and it's just little bleeps and bloops. So one of their other friends goes, hey, you know what? I think there's a little bit of a pattern to the way that this data is being tracked. If you apply the Doppler effect formula, I'm not a mathematician, so don't quote me on that, but they go, if we apply this formula to it, we could probably track the trajectory of where this is. So they start tracking it, right? And over the period of a month, they managed to track the whole trajectory of where Sputnik was. So that's really, really cool. Nothing really interesting of it. A couple months pass, and these two guys their boss pulls them in, and he goes, hey guys, I heard you guys were working on this project, that thing with Sputnik. They go, yeah. He goes, so if I understand it correctly, you managed to track the location of an unknown object in space from a known position from the ground. They go, yeah, that's basically it. He goes, okay, I have a problem. Would you be able to do that in reverse? Could you find an unknown object on the ground from a known object in space? And they go, let us crunch some numbers. We'll get back to you. So they go crunch some numbers. They come back and they go, actually, that's easier. He goes, great. Because I have this contract with the US military, and they want me to build some satellites so we can help locate the Russians. So if we need to fire a missile at Moscow from the Pacific Ocean, I know where my destroyers are. And that's how GPS was invented, actually. So 30 years later, they opened it up to the public, and I'm pretty sure everyone has a device in their pocket now that's able to communicate with one of these satellites. So yeah, it's really helping us with navigating us to our final destination. So thank you for your time.